For decades, computer security has run on a brutal, lopsided math problem. An attacker only needs to find one mistake to break in. The human defenders have to be flawless, patching every single vulnerability, all the time. The reality is that human engineering teams simply don't have the time to audit everything. We end up with a long tail of legacy code, decades of old software running quietly in the background, fully functional but riddled with hidden flaws. In April 2026, the engineering team at Mozilla recorded a set of results that broke the traditional math of vulnerability management. This line graph maps Mozilla Firefox's baseline bug fix rate through 2025. It remains mostly flat. Then, in a single month in early 2026, the line violently spikes. Mozilla patched 423 security bugs, a volume 20 times higher than their monthly average. A human team didn't suddenly work 20 times faster. This spike is the first hard proof that AI automation can parse and fix legacy vulnerabilities at a scale that finally outpaces the codebase itself. Earlier attempts to automate bug hunting failed because engineers tried using AI like a static reader. When they fed code into GPT-4, it drowned the team in plausible-sounding false positives, wasting hours of review time. Mozilla solved this by hooking a frontier model called Mythos Preview into an agentic pipeline. They gave the AI the tools to write and execute its own test cases. Before the model could report a flaw, it had to mathematically prove the vulnerability existed by building a working proof of concept. It turned plausible guesses into demonstrable facts. This autonomous proving ground uncovered severe flaws that had survived standard testing and human review for up to 2 decades, including a 15-year-old bug in a basic HTML element. By parallelizing this verification process, defenders briefly solved their scale problem. But this breakthrough relies entirely on a raw reasoning capability. The AI doesn't know it's playing defense. In that exact same month, April 2026, the UK's AI Security Institute was testing a checkpoint of GPT-5.5, pointing that identical reasoning capability in the opposite direction. This split-screen comparison shows the collapse of constraints holding attackers back. On a complex reverse engineering task requiring 12 hours from a human expert, the AI completed it in 10 minutes and 22 seconds, costing exactly $1.73. The Institute also ran an evaluation called The Last Ones to test the model's ability to handle long-horizon, multi-step operations without human intervention. This visualization maps the 32 steps the AI executed autonomously, breaching the perimeter, moving laterally, and exfiltrating a central data core. Researchers found no plateau. With increased compute budget, the model's offensive performance continued climbing. If a model can autonomously strip a corporate network for parts for under $2, we should be seeing mass infrastructure collapse right now. We aren't. The reason is that these highest-tier capabilities live inside closed systems. Users access them through monitored APIs, subject to rate limits and strict trusted access programs that can instantly revoke a malicious account. The AI Security Institute proved exactly how brittle that setup is. In 6 hours, researchers found a universal jailbreak bypassing all internal guardrails. These safeguards are a property of the deployment infrastructure. Once a model moves to private hardware, the monitoring and the filters are gone. That server infrastructure is about to become irrelevant. The capability to execute these chained attacks is rapidly diffusing into open-weight models, architectures that anyone can download directly to a local hard drive. This area chart tracks open-weight token flow on OpenRouter over the last year. Within 12 months, Chinese open-weight models surged from processing under 2% of traffic to over 45%, rapidly squeezing out the dominance of closed systems. The definitive gap in capability between the closed models and the open ones is a secret. We have an unknown number of months before a completely downloadable model clears the multi-step agentic bar that GPT-5.5 just crossed. The second that download finishes, the rules of cyber warfare reset. Every rate limit, monitoring system, and kill switch ceases to exist. On paper, we have defenses ready. Agencies like Germany's Federal Office for Information Security, alongside strict European baseline standards, provide massive institutional oversight. The vulnerability lies in the economic long tail. Hundreds of thousands of mid-sized firms, local municipal governments, and private utilities are running unpatched legacy networks, entirely devoid of dedicated security staff. When the cost of executing a complex cyber attack drops to zero, bad actors won't manually pick high-value targets. They will deploy autonomous agents to systematically farm this unprotected long tail. The Mozilla experiment provides the template. Defenders can use frontier models to parallelize their own code audits and test infrastructure, reaching parts of the estate that humans never could. We are currently operating in a window of months that no one can precisely count. The task is to use the existing lead in closed model access to patch the long tail before the open weight clock hits zero and the offensive advantage transfers to anyone with a GPU.